Hi, this is Stephen Brower from Raleigh Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And what this is going to be, this is accompanying Stallings Chapter 10. It's going to do an example of Booth's algorithm for signed multiplication using 6 bits. And I'm going to use minus 13 and 19 as the values that I'm going to deal with. And this video may end up being in multiple parts. I'm going to try to periodically take pauses, but we'll see what will happen. Okay, so I'm sorry, a reminder that when we do get into the algorithm, we're going to have a couple of things. So we're going to have A, we're going to have Q, we're going to have Q minus 1, which is going to be the bit that comes off of Q when we do a shift. And then we have M. And so what will happen is Q will be one number we're multiplying, M will be the other number we're multiplying. What will happen is M is going to be unchanged, but Q will eventually change. In the initialization, the A starts off at all zeros. And the Q minus 1 starts off at 0. Now for the Q and for the M, let's go and then figure out, for this example, what we're going to do. So for the Q, I want it to be minus 13. And for the M, I want it to be 19. Okay? Now, and we're using 6 bits. So to come up with the 6-bit 2's complement for minus 13, I'm going to first begin by doing 13 over 6 bits. So 1, 2, 3, 4, 5, 6. And the largest power of 2 that is less than that is 8. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. So these will be 0 in front. And if we subtract 8, we end up with 5. And so for 5, we have 1 in the 4's position, and then we have 1 here. So this is just the positive 13. So 2 to the 0, 2 to the 2, 2 to the 3. So 8 plus 4 plus 1. So to get to the 2's complement, we'll do a flip of the bits. And so everywhere there's a 1, we make it a 0. Everywhere there's a 0, we make it a 1. So it's just for each individual bit, we're reversing what's there. And then we add 1. So we add 1 to this. This is as part of the 2's complement. 0 and 1 is 1. And then since there's no carry, the rest of these just will come down. Okay, so what this here would represent, this is the minus 13. And you know what, let's just do a check. And the check will make sure that I have the number right. And I don't just mean stopping into a calculator and having it do the work. The check I'm going to do is if I take 13 and I add to it a negative 13, I should get 0. So if 13 is our 0, 0, 1, 1, 0, 1, and our negative 13 is our 1, 1, 0, 0, 1, 1, and now I'm going to add these two numbers together. So 1 and 1 is 0, carry the 1. 1, 0, and 1 is 0, carry the 1. 1, 1, and 0 is 0, carry the 1. 1, 1, and 0 is 0, carry the 1. 1, 0, and 1 is 0, carry the 1. 1, 0, 1 is 0. But since we're only dealing with 6 bits, we don't make a 7th bit. So our our 13 plus our negative 13, we ended up with 0. So it'll be this piece here. So 1, 1, 0, 0, 1, 1. That is going to be our starting value for Q. So our 1, 1, 0, 0, 1, 1. Our 1, 1, 0, 0, 1, 1. Is that right? Yeah, 1, 1, 0, 0, 1, 1. Okay, there's our Q. M. Okay, so our M, 3, 4, 5, 6. So the largest power of 2 that's less than 19 is 16. Sorry. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. Yay! So 19 minus 16 is 3. Okay, so 2 to the 0 is 1. 2 to the 1 is 2. 1 plus 2 is 3. 2 to the 2, 2 to the 3, 2 to the 4. 2 to the 4 is 16. So 16 plus 2 plus 1 is 19. So 0, 1, 0, 0, 1, 1. So 0, oh, my memory's so bad. 1, 0, 0, 1, 1 is our M. Now, at some point when we're working on Booth's algorithm, some point when we're working on it, we at some point are going to do something like A equals A minus M. Well, instead of having to subtract this here, which is the M, we actually can do it as A equals, A plus negative M. So if we actually come up with the 2's complement of 19, then later when we're need to subtract M, we can then add the negative M. So if our starting number, meaning our this is our 19, so we want to flip the bits. So everywhere there's a 1, there's a 0. Everywhere there's a 0, there's a 1. Then we're going to add 1. And just as a reminder, it's these two numbers here that we're adding together. So 0 and 1 is 1. And since there's no carry, then everything else just comes down. Okay, so this would be negative M, or negative 19. Let's check our work. So if I want to check just to make sure things are okay, we have our M 0, 1, 0, 0, 1, 1, and add to it the negative M, the 1, 0, 1, 1, 0, 1. Okay, so from the right-hand side, 1 plus 1 is 0. Carry the 1. 1 plus 1 plus 0 is 0. Carry the 1. 1 plus 0 and 1 is 0. Carry the 1. 1 plus 0 and 1 is 0. Carry the 1. I know I had a little funny little there. That is a 1. 1 plus 1 plus 0 is 0. Carry the 1. 1 plus 0 and 1 is 0. And so I just double checked that we had our that this negative M truly is the negative M. I'm probably going to be coming back here periodically. And so what I want to do is, just for emphasis, remind that this is M and this is our negative M. So if we do have to do A equals A minus M, it's this negative M that we are I'm going to be adding. Okay, so this piece up here, this is the initialization step. Okay, I need to draw a straight line, and this might be a disaster, so let me just pause so I can get a straight line in here. Okay, I got the line in there. I realize right now that this is at 10 minutes, and I think what I want to do is I'm going to stop this video. This part 1 is just going to be the initialization. Part 2 is going to begin with step 1. Yeah, let me just do that.